Today, I'll show you how Zener Diode is used as a voltage regulator using Proteus software. So before that, I'll explain why the Zener Diode is used as voltage regulator and how. Zener diode, it is a type of silicon diode with PN junction. So it is designed to operate in reverse biased condition. So this is the VI characteristics of Zener diode. This is in first quadrant, we get forward bias characteristics, and in third quadrant, we get reverse biased characteristics. In forward biased condition, Zener diode characteristics is same as that of ordinary PN junction diode. But in reverse bias condition, it is working in different manner compared to the PN junction diode. So here, the in forward bias condition, Zener diode, it just behaves as a normal PN junction diode. It allows the current to flow easily. But in reverse bias condition, it blocks the current. So see here, the current is very less. It is blocking the current. So up to where it will block the current? It will block the current till the applied voltage is equal to the Zener breakdown voltage. This point is called as a Zener breakdown voltage. When the applied voltage becomes equal to the Zener breakdown voltage, so up to that, it will block the current. Beyond this voltage, the Zener diode will allows the current to flow through it. So, but it keeps the voltage across it constant. So this is called as Zener breakdown voltage. So in reverse bias condition only, we use Zener diode as a voltage regulator. So this is a symbol of Zener diode, and its primary purpose is to maintain constant voltage across the circuit. So even though you change in the input voltage, even though you change in the load condition, it maintains the constant voltage. For that purpose, Zener diode is used as a voltage regulator. Then Zener diode depends on the type of Zener diode you used. For example, if you are using 5.1 volts Zener diode, so it maintains fixed 5.1 volt across the load. Suppose this is your circuit. Here you are applying the DC voltage, and the series resistance you are connecting to as a current limiting resistor. And check the Zener diode status here. It is always connected in reverse biased mode. It means the cathode must be connected towards the positive of the supply and anode must be connected towards the negative of the supply. So it is always connected in a reverse biased mode. So this Zener diode always maintains the fixed voltage 5.1 volt across the load. Even though you change the input voltage, it always gives the constant voltage. So suppose if you are increasing the input voltage, the current through the Zener diode also increases. But the excess voltage is absorbed by this series resistance. If the input voltage decreases, the current through the Zener diode also decreases. But the voltage across the load, it remains constant. That's why Zener diode is used as a voltage regulator. So because of this output, constant voltage, they are used, Zener diode as a voltage regulator is used in computers, power supply, alternators, generators, etc. So now I'll show you how to draw the circuit in a Proteus. So this is the circuit I have already drawn and taken the output. So here I should connect the DC supply. In order to make this as a variable DC supply, I am connecting 1 kilo ohm pot here, and to measure how much voltage I am varying, that I will measure with the help of the voltmeter, DC voltmeter. And to limit the current, I am connecting 220 ohm resistor and Zener diode across the load. This is a load. The load I am choosing as a pot in order to fix the correct current, and this is the output voltage DC voltmeter to measure the output voltage. Now I will show you with the help of the Proteus software. So here First, I'll show you what is line regulation. Line regulation means you should vary the line voltage and measure the output voltage, keeping the load current constant. You should keep this current constant and vary the input voltage and measure the output voltage. This is called as a line regulation. So this experiment I'll show you now. So you should go to Proteus. So here, choose the new project. Okay. So go to next. I'll give the name of the project as line regulator. Line regulator. Okay. So click next, 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 and finish. Okay. Now I'll minimize this. Like this, we should draw here. So first go to the pick component mode. Here you should choose V source. So this DC voltage source you should select by typing V source. Okay. So click OK and place here somewhere here. Right click on this, go to edit properties. Here I want to choose the source voltage more than the Zener voltage. Here I am going to use 5.1 volts Zener diode. So I am using more than that source voltage, 14 volts I am using. Next, I need one pot. So go here, type pot. So select the active pot. Click OK and place somewhere here. Okay, like this. So and that should be 1 kilo ohm pot. Then I need one voltmeter. Click on instruments. DC voltmeter you place here. Next, you need one resistor. Check here for resistor. Okay. So I'm using generic resistor. And I'll connect here, somewhere here. So the value of this resistor, right click on this, edit properties, 220 ohm. Click OK. Next, what you need, I need Zener diode. Go to pick component mode, type Zener diode. Zener diode, I'm using 4 point, anything you can use, I'm using 4733 amps. 5.1 Zener diode I'll use. 5.1, 4733. This Zener diode I am using. Okay, then you should connect always in reverse bias mode. Click on write property, anti-clockwise direction. Then in order to measure the current flowing in the Zener diode, I need DC ammeter. Place here DC ammeter. Then I need to take one pot in order to fix the load current. So already I have taken one pot here. The same pot I'll choose here. And I'll fix the value as 4.7 kilo ohm. 4.7 kilo ohm. Click OK. And in order to measure the voltage, I need voltmeter. Again, go to instruments. DC voltmeter you choose and place here. Okay, these are the components required. Now, according to this, see the right side. So according to this, you just connect all the components. Okay. So connect the positive terminal. Okay. And into terminal. Okay. So little zoom I'll do. Okay. Next, this should be, wiper should be connected to. So I'll connect the wiper here. Okay. And this resistor to this end. And this resistor to ground. And from 220 ohm resistor to cathode. And from anode to ground. And DC emitter to Zener diode. Okay. Then this to ammeter. This to ground. And this wiper to, just check here, wiper where you have connected. Wiper to ground only. Okay. And this voltmeter across the load. Okay. Now the circuit is ready. 1 kilo ohm pot. This is the voltage. Now I'll show you how to get the characteristics. After turning on, how to fix the load current and how to vary the voltage. Next, for 2.6, I am getting 1.99 volts. I'll show you. For 2.46, I am getting 1.99 volts. Next, for 3.56, it is 2.88. For 3.56, 2.88 volts. Next, 4.64 input voltage. It is 3.76. 3.76. Next, for 5.76, output is 4.67. 5.76 output is 4.67. This I have already copied in order to save the time. Next, 6.67 output is 5.08. 6.67 output is 5.08. 7.51 output is 5.11. Output is 5.11. Next, 8.64 output is 5.13. 8.64 output is 5.13. 10.4 output is 5.15. Output is 5.15. 10.4. 13.9 output is 5.16. 5.16. Okay, these are the readings I have taken. At the same time, you can observe the current also. For 0.01, current is 0.01 milliamps. It is 1.3, 1.12 milliamps, 2.12 milliamps, 3.07 milliamps, 4 milliamps, 4.96 milliamps, When the voltage becomes 5.08, current is 5.04. When voltage is same 5.11, current is increasing to 5.44. 5.13, current is 5.46. 5.15, current is 5.47. So why this is happening, I'll show you now. Stop the simulation. So first, using this pot, you should fix the load current. So how I am fixing the load current? I am fixing the load current to using 4.5 point. You should keep the input voltage to some value. So more than the Zener voltage. I have chosen 5.1 Zener diode. So more than that you should choose. Let me take 8.64. For that, it is giving 5.46 milliamps. This you should fix. So if you want to vary the current, you can vary using this pot. See, for previous step, it is giving 3.64 milliamps. For next step, it is giving 5.46. I'll fix this load current. Fix this load current for 8.64 volts. Now you start taking the readings from 0 volts. 0, 0.01, 1.3, 2.46. Like this, you take the readings. So what we did, we kept the load current constant using this point. So to keep the load current constant, first you should choose the source voltage more than the Zener voltage. So which voltage I took? So I took 8.64 volts more than the Zener diode, and I fixed the load current constant. So after that, you bring this wiper to the lower position, then start taking the readings. It means you are making the load current constant and you are varying the input voltage and measuring the output voltage. So after writing this tabular column, V input and V output, select this complete tabular column, go to in Excel, go to the click on insert button, click on scatter and choose this graph. Okay, so there are many graphs here. Choose this graph, that is scatter with straight line and markers. So I'll get this graph. So you can check the graph here. For lower voltage, the current and the output voltage keep on increases. And when it reaches the Zener voltage 5.13, the output voltage almost remains constant. So for this purpose, Zener diode is acting as a voltage regulator. Now here you can write the, do the labeling also. So go to the layout and here title you can give x-axis title. So here input voltage versus output voltage. So this is V input. Okay. So this is V input and here you can give the vertical axis V output. V output. Okay. And you can change the title of the graph. Zener diode as line voltage regulator. So in this way, you can give the title. So in this way, you can draw the waveform graph in Excel sheet. So this is all about Zener diode as a voltage regulator using Proteus.